Thank you for that. Okay, so I've turned on the record button. So thank you. This is Matlab code. Is kind of the same. It's kind of similar to what we did in Excel Visual Basic. It's just that the syntax is different. So in Excel, when we wanted to declare a variable, we said dim G as double, but here we just say G is equal to the value we want. So Matlab is much, in terms of the syntax, it's much fairer, but it's not so great when you want to update values and everything, like we saw when we were doing it in Excel Visual Basic. So this is the syntax in Matlab. So I'm sure you guys are familiar with this. This is the G, acceleration due to gravity. Here we are specifying that the user should input the mass. This is the coefficient, air resistance coefficient. Ti is the initial time. Tf is the final time. Vi is the initial velocity. The T is the step size. Then this is similar to what we did in Excel Visual Basic. So we assigned this line was there. We assigned Ti with T, Vi with V, and the T with H, because we don't want to use these values directly, because if we use it directly within the function, the values are changing within the functions, and we don't want the values to change. So that's why we need to specify another variable for that. And in Excel Visual Basic, you have to declare a variable before using it. Like you have to say dim T as double. But in Matlab is very direct. You don't need to declare the variable, just use it straightforward. That's Matlab. Then this while function, we also add a while function when I was explaining it in Visual Basic Excel. We also had a while function. So it's exactly the same thing. It's just that the syntax is different. So we use a do while loop in Excel Visual Basic, but the syntax in Matlab, we're using a while loop. Then the syntax is you create the while loop, then you have to end it using the end keyword. But in Visual Basic, you have to say do, then while. So the syntax is just different. So you need to know the syntax. So all I'm just saying is that this was the same thing we did in Excel Visual Basic. It's just that the syntax is different. For here, when we wanted to break out of the loop, it was a different syntax we used. So let me explain this code again, because sorry, why the one beside the while loop? Okay, that's a good question. The Y1, we call it a Y1 loop in programming. And the Y1 loop is an infinite loop. So the Y1 loop will keep repeating indefinitely. Is an infinite loop. It's going to keep on repeating to infinity. So that's why we call it a Y1 loop. While 1. So 1 is always true, because in Matlab, 1 is written as true. So you can also put it as while true, but it's still the same thing, Y1. So we call it a Y1 loop. A Y1 loop is an infinite loop. It's going to keep on repeating till infinity. The only time it's going to stop is when the condition within the loop is satisfied. And that condition is that if T is greater than TF, that means that if you've reached the final time, then it's going to break out of this loop. It's going to break out of the Y1 loop. Otherwise, if this condition is not satisfied, the loop is going to continue repeating till infinity. So in Visual Basic, it was the do while loop we used. And the do while loop is also similar to the Y1 loop, because there was also a condition within the loop. That do while loop is also the same thing. So once that condition is satisfied, then you're going to go out of the loop. You're going to break out of the loop. So let me just repeat it once more. So you have this, okay. So we have this if statement. So what this if statement is saying is that if t plus the t is greater than tf, that means that if you've reached the final time, then do this. Then set the time step to be tf minus t. So this is saying that you should set the time step to be the final time minus t, where t is the initial time. So that means that if you've reached the end of the loop, you should do this. And if you've reached the end of the loop, it's going to do this assignment statement. It's going to execute this. This being the model. Remember, this is the model in programming form. Then this is the Euler's this is the main function of the Euler's method, because this is the initial velocity. This is the new velocity. Then this is v dot, and this is the time step. So this method is the most important in the Euler's method, while this is the model, because our model is g minus c divided by n times v. Then it's going to do this, then to do this line. Then once it gets here, since h is equal to tf minus t, that means that t is equal to tf. And once t is equal to tf, that means that this condition is satisfied. Then it should go out of the loop. So what this if statement is directing us is that once we have reached the final time, we should break out of the loop. We should leave this while loop. That's why you have this. Then the remaining, this is the model in programming form. This is the Euler's method in programming form. And this is just incrementing the time step, telling you to increment the time step by h. And the t is equal to h, then the t is 0.1. So it's going to keep incrementing the time step by 0.1 time step. So that's what this function is in MATLAB. So let me save it. So once you've gotten a new script, you have to save it. Let me save it as falling objects. I know you all know how to do this. Then you're going to save it as a .m file. So after saving it, you already have it saved. So in order to run it, you just click on run. You can click on run here, or you go back to the command window and just type falling object. Remember, we saved it as falling object. So you just type falling object. So now we need to it's asking us to input the mass, because in the code, you need to input the mass. So let's input the mass as 134. So once we input the mass, it's going to tell us the velocity using the Euler's method. So we wrote a function, or we wrote a script in MATLAB to use the Euler's method given our model. So the Euler's method is very important, and we are going to keep on using it. So is worth knowing. You should know how to write the code in MATLAB and also in Visual Basic, because I'll be using Visual Basic alongside MATLAB. I'll be using Excel alongside MATLAB in this course. So you should know how to write it. So like I said, if you want to go back to the command window, you just go, because we saved it as falling object, you just type falling object. I can change the mass to 56, then it's going to give us a different velocity. Then we want to convert it to a proper function in MATLAB. So in order to convert it to a proper function in MATLAB, I have another code. So the code is also in your notes. So you go to new script. I'm writing another script. And this is the Euler function. Is the same thing with what we did in Visual Basic Excel. It's the same thing. It has 6 parameters. It's just that the syntax we're using in Visual Basic is different from the one we use in MATLAB. The syntax in Matlab is much more easy, I think, than in Visual Basic, but I'm going to be using the two. So we've written the function. Then the name of the function is EULA, not the double R. The reason why I'm putting the double R is because there's a predefined function already in Matlab that is EULA. So if I use this normal EULA, is going to give me an error when I try to run it. So I decided to just use double R so that it will not confuse the predefined function, which Matlab already has, with the function I'm defining, because I'm defining the function now. So that's why I just use double R here. Then when you want to save it, you have to save it as the name of the function. So when I'm saving it, I have to save it as exactly the name of the function, what I have inside the command window. If you don't save it exactly the name, in fact, when you click on save, like once you click on save, it's going to default save. It's going to default to the name you have here. It's going to default to the name you have here. So don't bother changing it, because that's the way to do it in Matlab. So save. So if you have a function for the EULAs to do a numerical solution using Euler, then we need to write another function to for the model we have. So the code is in your notes. Then I save it. It's going to default to the name of the function you have here. You have the Y here, so don't bother changing it. Then save. So we have two functions now, Euler's function and the Y function. Okay, y is equal to y. What does that mean? Okay, all right. Okay, thank you for that question. For when you're writing a function in Matlab, this function is going to return a value. So the value is going to return is y. So now what we are saying is that this value at the end of the day, this is the final value is going to give us at the end of the day. So what we are saying is that we should assign that value to yy. So when you are defining the function, you have to, if the function returns a value, in this case, this function returns a value. So we just define another variable, yy. And that yy represents where to store the return variable. So this is our final result. This statement, remember I told you that this is the most important line in the Euler's function. So it's going to, this value is going to indicate the value you got using the function. So what it's saying is that after getting that value, just put in this value inside yy. So this is the syntax. So it's just a syntax. And what the summary is that when a function returns a value, you have to define it this way, specifying a variable name where the return value should be put in. Then at the end of your calculation, you have to put in the final value into the same variable name you defined at the first line of your function. That's what it simply means. Then for this case also, you have, all right, thank you. So we are going to, so we define the two functions now. Then we are going to write, we are going to, so we are going to type in some Matlab commands into the command window. So we specified the mass, the air resistance coefficient, the initial time, the final time, the initial velocity, and the step size. Then this is the function we defined, Euler function. So these are the parameters we use. It's kind of the same thing with what we did with Excel Visual Basic. So when we do that using the Euler's the Euler's method we defined, we can actually get the final value. So if we change the parameters, let me change this one to 168. Let me change this one to 10.5. Let me change this one to 2.5 and probably this one to 0.01. You're going to get, okay, it's giving me an error because of this. So I made a mistake here. So let me just correct it. It's supposed to be 2.5. So it's going to give us a different value. So this is how to write a function in Matlab in order to calculate the Euler's, in order to solve a model using the Euler's method and using the analytical method. So this is the end of the class. So let me just summarize before we leave. So this class is numerical methods using Matlab, but I already said that unofficially you're going to be using Visual Basic. Like one of the, we can see the results in Matlab, but if we were to plot it, we can plot the values, but we can plot the values in Matlab, and I know you know how to plot, and I know all of you know how to plot the values in Matlab using the plot function. But one thing with Visual Basic is that Visual Basic is direct. Like when I wanted to change the values in Matlab, I had to type again and copy and paste and change the values. Then in order to plot it, I have to write a plot function that will keep plotting in it anytime I change the values. But in Excel Visual Basic, things are much more straightforward. Immediately I change the values, you will see that all these parameters will change. And you see they've changed, and even the graph is updated. So that's why I'll be using Excel and Matlab together with this class. So we developed the model of a falling ball. Then we derived the analytical solution, and we also developed a numerical solution using Matlab. We developed a numerical solution using Euler's. And so we had this model. We proved the analytical solution. Then later we did the AND calculation. And we discovered that using the AND calculation is good actually, but it could be better if we use the computer. And we finally used the Euler's method because I told you that some models, this particular model we are using is a very, very simple model. It's very, very simple, and in engineering, you will not even come across a simple model as this. This is just for illustration. And we're able to solve it analytically because it's very simple. There are some much more complicated models that is not possible to solve it analytically. If you want to solve it, you just spend the whole day solving it. So it's better to go through the numerical, through the numerical solution using Euler. So we went through the AND calculation. So we discovered that the results are not so, they are not so close. There's an error. Then we'll say that if we use a smaller step size, we could get a better approximation for the analytical solution. But if we use AND calculation, it will be very tedious. So we decided to use Visual Basic, Excel Visual Basic, then we used Matlab. So this is the end of the class. So like I said, when I started the class, this is my final comments before I end the meeting. So when I started the class, I said that you have 100%, 70% exam, then 30% is continuous assessment. Part of your continuous assessment, 10% is for assignments and tests. So all the assignments have been given you a module. At the end of the day, we're going to collate it together, which will form your 10%. Then there's also going to be a test. So the assignments and tests is 10%. Then there's going to be a project. That project is 20%. So it's 2 in a group. When I get to midway in the class, I'm going to be assigning the project to you guys, and that project is 20%. Then the exam is 70%. So thank you all for joining me in the class. Like I said, I'm recording this, so immediately after. So what's the project on? I'm going to be, please, ma, help us drop the notes. The note is already on Moodle. The note is already on Moodle. So if you go to your Moodle, you will see it. And it's going to be the project, when it's time for me to give the project, is going to be numerical methods with Matlab. So, and it's going to be self-explanatory. And you're going to be two in a group. So I'll soon give the project out, but probably midway through our lectures, or when we have 2 or 3 lectures more, you'll be receiving your project. Okay, the recorded lecture, I'm going to be posting it on Moodle. So I've recorded the 3 sessions we had. So I'm going to post it on Moodle today so that you can go over it and you can do it on your own. And like I said, the Matlab is very important, and the Visual Basic Excel Visual Basic, because I'm going to be using Visual Basic a lot, and more of Visual Basic and less of Matlab. So that's going to be my strategy for the course. So thank you all for joining me. We're going to see you later. Bye-bye.